recording in a moment. And recording is trying to turn on the recording process. Hopefully we'll get there. We have 5 people here, so there we go. We go back to the PowerPoint. So meninges, the layers that surround the brain. The dura mater is the tough outer layer, the tough mother. Epidural space is above the dura of the spinal cord. When women give birth, they get an epidural with a narcotic sent into the space above the dura mater, and that allows deadening of the pain of childbirth. So epidurals are very common, administered to a pregnancy and delivery of the fetus. The spidery level is the arachnoid level. It has a subarachnoid space where the cerebral spinal fluid circulates all around and in the vesicles of the brain, and the movement of that fluid all the way down through the spinal cord. The thin interlayer is called the delicate mother, or the thin layer. So those are the meninges, the coverings of the brain. What do they look like? Here we have the skull, the dura mater, the dural sinus, with the two layers of the dura mater, then the arachnoid and the subarachnoid space where cerebral spinal fluid can circulate around and into the vesicles of the brain. So that fluid is very, very important for helping to nourish and helping to support the brain cells, to give them a little more oxygen and a little more get rid of waste and so on. So that cerebral spinal fluid is moving through in the subarachnoid space. In the spinal cord, we have the bone of the vertebrae in this epidural space, that where the epidural is allows injection of painkiller in the vertebrae to help deaden the pains of childbirth. Then we have a dura mater, the arachnoid, the subarachnoid space, and the pia mater. So spinal cord basics: relays information to and from the brain, processes some information on its own. There are 31 segments. We'll point out these structures and where the gray matter is in the spinal cord and where the white matter is. So you have the spinal nerves classified by the segment of the spinal cord where the nerves leave, but also information comes and goes in cervical spinal nerves, which send information and receive information in the neck region, and then the chest region, and then the lower back, and then the sacral region. So if you look at a cross-section of the spinal cord, notice that this gray matter is surrounded by white matter. The sensory input into the spinal nerve goes through the dorsal root ganglia into the dorsal root, into the posterior gray horn. So this is the posterior sulcus. Here's the interior median fissure. Remember, a sulcus is a slight depression in between slight elevations. We don't call these gyri. This is called a sulcus. So sensory information comes in, goes to interneurons. The interneurons analyze and connect to appropriate motor neurons in the lower or the ventral or anterior horn of the gray matter, and then the motor output leads to through the ventral root and a lot of that is contraction of skeletal muscles, and also motor output to the gut, heart, lungs, kidneys, bladder. All that automatic function comes out here too. So if we move on and we look at the fine arrangement of where the somatic input comes in from the muscles, from the visceral, which is the autonomic input, which allows information again from the heart, the lungs, the bladder, the state of muscles and everything, almost the smooth muscle function. So input comes up, remember, through the dorsal root ganglion, through the dorsal root into the top of the horn, which is called the dorsal gray horn, or the dorsal or posterior horn. Information from muscles, from joint position, muscle contraction, all the information of what's happening in all the systems of the body, digestion, respiration, urination, all these respiration and so on. All this information enters this part of the gray matter of the spinal cord, and it's first of all enters, and then it's analyzed by interneurons, and then information is sent out to slow your heart or speed your heart, to cause peristalsis or movement of the gut for movement of food and mixing of food in your digestive system. And then the somatic motor is where information from this sensory information from up here is processed, and information is sent automatically through the ventral root back to muscles, where muscles contract and you walk, you talk, you read, you get up from a chair, you sit down on a chair, you ride a bike, you drive a car. All that somatic motor input goes back to the muscles. All of this visceral motor goes through all your automatic functions of the autonomic nervous system, the dilation of your eyes, the secretion of salivary glands, the beat of your heart, the contraction or relaxation of smooth muscle in your blood vessels. So the somatic input from the muscles is analyzed by interneurons, and the output comes from the somatic motor. The input from all of your automatic functions is received here, processed, and then sent out from nerves that have connections to interneurons, so that's sent out again. So afferent input comes in here, efferent output goes here. We can look at a slide of a spinal cord. You'll have questions in WebAssign where you'll have to identify all these structures. They're pretty straightforward. So make sure you take a look at this and the previous image. So the gray matter has motor nuclei and sensory nuclei of the nerve cells. And the spinal cord surrounds the central canal. Sensory nuclei are dorsal, motor nuclei are ventral. A thick white matter surrounds the gray matter with ascending and descending axons going in columns of axons, and they go to various parts of the brain, and we'll talk about how those columns take information to the brain and send information from the brain back through the spinal cord for higher level control of nerve function by connecting the spinal cord and the cerebral cortex, for instance. Okay, let's stop there and turn off the stop recording.